All right, welcome class. Today we're going to go over section 4.2, Apply Congruence and Triangles. The important thing to remember for this section is that we are basically learning one definition. The definition we are learning is the one for congruent figures. Okay? Now, in congruent figures, all the corresponding parts of one are congruent to all the corresponding parts of the other. Another way to think about congruent figures is that they are the same shape and the same size. Okay? They are exactly the same. If you slide one around, you can slide it right on top of the other. Corresponding parts. You will see in the next example that when we go to write a congruent statement saying that one triangle is congruent to another, the corresponding parts need to line up. Okay, so again, we'll see a little bit more of that in the example right now. So, example 1, write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. Now, the important thing to remember when writing a congruent statement is that you have to line up the corresponding parts. In your notes, it's off to the side over here. But they say one way to see the corresponding parts is to move one triangle around so that they all line up. Now, I'm going to go over the second part of this, the corresponding angles and the corresponding sides first, and then we'll write the congruent statement. Now, we can see that angle A is congruent to angle F. Angle B is congruent to angle G. Angle C is congruent to angle H. If we look at our sides, side AB is congruent to side FG. Side BC is congruent to side GH. And side CA is congruent to side HF. So those are all of our corresponding parts. Now, when we go to write our congruent statement right here, you have to line up the parts of one triangle. Here they've got triangle ABC congruent to triangle blank. So when we fill that in, we have to make sure that all the corresponding parts line up. Now A corresponds with F. So it would be triangle F. B corresponds with angle G. So B is in the middle, G would go in the middle. And then finally C corresponds with H, so that would be triangle FGH. That is our congruent statement. Again, the corresponding parts need to line up. Now, those can change. Let's suppose, for example, that I said write the congruent statement for triangle BAC. Well, for that one, it's still the same triangles, but now our parts are in a little bit different order, so the second one would have to be the same. B corresponds to G, A corresponds with F, and C corresponds with H. So that is the same statement as that one. Okay? It's just like you can write segment AB as segment AB or segment BA. They are the same thing. Triangle ABC and triangle BAC would be the same. Again, you just have to make sure that your corresponding parts all line up. All right, example 2 here. In the diagram, we know that polygon QRST is congruent to WXYZ. So right away I know that Q and W are corresponding parts, R and X are corresponding parts, S and Y, same thing with T and Z. So those will all be the same. So we know from this that Q and W are corresponding parts, so they will be congruent. So the measure of angle Q equals the measure of angle W. Substitute, the measure of angle Q is 65 degrees. So the measure of angle W is 5x plus 5. We just need to do a little bit of algebra here. Subtract 5, and then divide by 5, and we get x is equal to 12. So there's part A. Part B, find the value of y. Well, if we look, QR and WX are corresponding parts. QR is 6 inches long. WX is y minus x. Well, we just solved for x. That was 12. So 6 equals y minus 12. Add 12 to both sides and we get y is 18. They didn't ask us to find any side lengths, just the value of the variables. So we are done with example 2. All right, go ahead and do checkpoints 1 and 2 on your own. Pause the video, work them out. When you're done, hit play and we'll go over the answers. Okay, so here are all of our pairs of congruent and corresponding parts. Here are the 4 sides right here and the 4 angles right here. Now, for the second part, find the value of x and the measure of angle G. Well, we know that angles G and T are congruent, so the measure of angle G will equal the measure of angle T. That's 2x minus 7 equals 103. Add 7, we get 2x equals 110. Divide, we get x equals 55. Okay, so there's the value of x. Now, for the measure of angle G, you can either plug 55 back in, 2 times 55 minus 7, or just realize G and T are congruent. If T is 103 degrees, G is 103 degrees. Plug it in. Check it. You'll see that it works. All right, show that figures are congruent. Now, by definition, okay, for 2 figures to be congruent, all corresponding parts need to be congruent. So when it says show that figures are congruent, we need to show that all the corresponding parts are congruent. Okay, so if we go through this from the diagram, we know that angle S is congruent to angle Q because they are right angles and all right angles are congruent. Also, by the lines perpendicular to a transversal theorem, line PQ is going to be parallel to line RS. Okay, that's the top is parallel to the bottom. Then angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3 by the alternate interior angles theorem. All right? So all pairs of corresponding angles are congruent. So we've got all of our angles. Now we need to show all the sides. The diagram shows that PQ is congruent to segment RS. Segment QR is congruent to segment SP. So by the reflexive property, segment PR is congruent to segment RP. So that is congruent to itself. All the corresponding parts are congruent. So triangle PQR is congruent. Now, I want you to fill that part in. Remember, corresponding parts need to line up, so there is one correct answer to go in that blank spot. So pause the video, write it, and then check your answer. Okay, so first of all, PQR is the top triangle. So P on the top triangle corresponds with R on the bottom one. Q is our right angle on the top triangle. S is the right angle on the bottom. And then the third point, R on the top, corresponds with P on the bottom one. So you should have had triangle RSP. Anything else is out of order. So, yes, the 2 sections will be the same size and shape. So they are two congruent triangles. Okay, so go ahead and do checkpoint number 3. Make sure you know that, or make sure you've got the given information. Remember, to show that triangles are congruent, you have to show that all 6 corresponding parts are the same. All 3 sides, all 3 angles. So go ahead and do that, and then we'll check your answer. Okay, so here's the answer. Let's go through this to make sure you understand it. Now, by definition, you have to show that all 3 sides and all 3 angles are congruent. So let's go through and do our checkpoint here. Now, from the diagram, we know that AB and CD are congruent. So there's one pair of sides. Point E is the midpoint of AC and BD. Now, midpoint means that both halves are congruent. So AE and CE are congruent. BE and DE are congruent by definition of midpoint. That's our second and third sides. So all of our sides are done. Now, if we look at the angles, okay, the important thing to remember about the angles is that we have got parallel lines here. So, since those are parallel, we know that angle A and angle C are congruent because they are alternate interior angles. B and D are alternate interior angles for transversal BD. So there's 2 pairs. Now, the 2 angles in the middle, angle AEB and angle CED, are congruent because they are vertical angles. So there's all 3 of our angles. So all 3 sides, all 3 angles. So yes, we can say the 2 triangles are congruent. All right, third angles theorem. All this says that if you know 2 angles of one triangle are congruent to 2 angles of another, then the third angles are also congruent. Okay? Go back to the triangle, the proof of this, go back to the triangle sum theorem. Triangle sum theorem says that all 3 angles of a triangle add up to 180. So A plus B plus C equals 180. The measure of angle D plus measure of angle E plus measure of angle F equals 180. We can subtract A and D because they are congruent. We can subtract measure of angle B and measure of angle E because they are congruent. That leaves us with the third angles having the same measurement. So the third angles are congruent. All right, so that's the third angles theorem. Properties of congruent triangles. Just like for angles, just like for segments, triangles are both reflexive. So triangle ABC is going to be congruent to triangle ABC. Symmetric, so we can switch the order. If triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. And transitive property. If the first triangle is congruent to the second triangle and the second triangle is congruent to the third triangle, then the first triangle and the third triangle are going to be congruent. So triangle ABC is congruent to triangle JKL. All right, use the third angles theorem. So find the measure of angle V. So that's the angle that they want to know. And if I look, I don't have a whole lot there. But if I go through this, I can start finding some other stuff. Now, we know that angle SUT and angle VWU are congruent by the vertical angles theorem. Okay, so SUT, VUT. So the diagram shows that STU is congruent to angle VWU. So by the third angles theorem, angle S and angle V would be congruent. We're dealing with these 2 triangles right here. Okay? So by the triangle sum theorem, the measure of angle S is going to be 180 minus 66 minus 44. So that's 70 degrees. So angle S, angle V are both 70 degrees. Okay. Go ahead and figure out how to get the measure of angle D. Again, pause the video, and when you're done, check your answer. Okay, so I think the easiest way to do this is to realize you've got two vertical angles here. So angle AEB is also going to be 47 degrees. And if we look at triangle ABE, the measure of angle A is going to be 180 minus 71 minus 47. So the measure of angle A is 62 degrees. And from the picture, angles A and D are congruent, so the measure of angle D is 62 degrees. All right, prove that two triangles are congruent. So we have to show all sides, all angles. Whoops. That was the end of fifth period, guys. Okay, so prove that two triangles are congruent. So we'll use the reflexive property to show that the side that they both have in common, to show that segment HG is congruent to segment HG. And then we'll use the third angle theorem to show that angle F is congruent to angle J. All right? So we know that FH and we know that FH and JH are congruent. That was given. We also know that FG and JG are congruent. So that's two of our three sides, and again, that was given. Like we said, we're going to use the reflexive property to say that segment HG is congruent to segment HG. All right? So there's all three of our sides. Now we need all three of our angles. Well, again, angle FHG and angle JHG, angle FGH and angle JGH were both given. So that's two of the three angles. And like we set up in the plan, we can show that with the third angles theorem that angle F is congruent to angle J. So if I was going through a checklist, you would see here's my three sides. Here are my three angles. So I've got all six parts. So I can say that the triangles are congruent. And notice, they do have the corresponding parts lined up. So the triangles are congruent by the definition of congruent figures. Okay, by the definition of congruence, what additional information is needed? So go ahead and write it down, pause the video, and check your answer. Okay, so the stuff that we know, all right, we know that we've got one pair of congruent sides here. AE and DE are congruent. So we would need two other sides. We would need that segment AB was congruent to segment DC. We would also need to know that segment BE is congruent to segment CE. So those are the ones that we were not given from that. Now for the angles, okay, the angles are a little bit different. We know that we've got angle A and D congruent, all right, and we know that vertical angles are congruent. So even though they didn't mark it, we know that's 47. So the only one we don't know is that the measure of angle C is 71 degrees. So once we figured all three of those, if we could, then we could say that the triangles are congruent. All right, well, that's today's lesson. So hope you enjoyed it, and tomorrow we will actually learn some shortcuts for this. So see you tomorrow in class.